So we're going to continue our look at the gas laws, and the two variables we're going to look at in particular here are volume and pressure. We're going to keep temperature constant, and when we look at the effect of volume and pressure on each other for a gas, this is known as Boyles Law. Let's take a look at it conceptually here with our little video. And we can see that as the temperature is kept constant, we can see the effect as the volume decreases, the pressure increases. It's an inverse relationship. We can watch it one more time. Again, we can see pressure increasing as the gas gets crushed. Now, you're familiar with this gas law. If you take a balloon and you squeeze a balloon, the gas pressure inside the balloon increases greatly, and this is Boyles Law. So we can think of it as kind of the B for boil, B for balloon, squeezing a balloon. You're changing the volume, which increases the pressure, and the temperature stays the same. So let's take a look at it mathematically. So mathematically, we've got V1 P1 over T1 equals V2 P2 over T2. Temperature is held constant, so we can cross off temperature for a Boyles Law problem. So any Boyles Law problem, you can disregard temperature. And so now let's say that we have a container here. I'll draw the problem up and then we'll take a look at it. Okay, so with all the gas laws, again, we have to make sure that our units are the same for each. So we have the initial volume, so I'm going to label this for our container of gas. The initial volume is V1. So this equals V1, and this equals P1. Okay? So I have to check, is my V2 also in liters? Yeah. So I can continue, and this is my unknown. So we're solving for P2. What's the pressure of the gas if the volume goes from 2 liters to 1 liter? So we're decreasing the volume. So we can now plug into Boyles Law. So we can say 2 liters times 100 atmospheres equals 1 liter times X. And we solve this for X, and we end up with 2 over 100 ATM. And here again, it's why it's important that the variable that you have on both sides has to be in the same unit. So now we see the units of liters cancel, and we're left with just the units of pressure. So 2 times 100 gives us a total pressure of 200 ATM. And that is a Boyles Law problem.